Okay, so welcome back. We are very close to finish the derivative chapter. I think it's just two more. And what we're going to do today, we're going to look at the derivative of the function that we've worked before in the beginning of the year, e to the power of x. Let me just see, is this working? What do you... Okay. Now, I'm actually going to give you the answer straight away. Okay? The answer is e to the power of x. So it's a bit weird, not weird, it's actually fantastic. It's a very special function, this e to the power of x. It's the derivative of that function is the same as the function, which is quite extraordinary. I'm going to just talk a little bit about more, but first of all, I think I probably need to remind you what e is. Okay, you maybe forgot what e is. So e, and maybe I'll write it here, that's the definition of e. E, this is, I think, pretty much what we started with this year, is 1 plus, let's call it h this time, to the power of h in the limit where h approaches 0. Okay? So, if you think about it, 1 plus, instead of h, we'll write 0. 1 plus 0 is kind of, it's a number that is very close to 1. It's 1.0000 billion zeros, count on 0, but it's very close to 1. No, hang on, sorry, I made a mistake here. That should be 1 over h, of course. Okay, so it's a number that is very close to 1 power. What is 1 over h, where h is 0? What is 1 over 0? Infinity, you said. Okay, so naively, I'm going to remove it in a second, but it's kind of like 1 to the power of infinity. So you've got like two kind of powers here. This is 1, and you know 1 power everything is, what is 1 power, 2 power, 3 power, anything, is 1. So it really kind of wants to be 1, but because it's infinity, we're timing it by itself infinity time, and it's not really 1, it's just a number as close as possible to 1 as possible. Then this one pulls it to infinity, because obviously when you time the same thing again and again and again, you're getting a bigger and bigger number, if it's a bigger number than 1. This keeps it close to 1. So what you get is the number e. Okay? And e is 2.718. Okay, I'll write it 2.71. There's a whole bunch of, it's an irrational number. Okay? I'm going to just get rid of that one because that's mathematically really not right to say. Okay? So it's 2 to the point 2.71828. Okay? So that's the definition of v. Okay? All right. What's the derivative? Okay? So I'm going to prove that. That's really this whole lesson. That's whole lesson, but I need to prove that. So what is dEx to dx, the derivative of e to the power of x? Well, if you remember, it's basically e to the power of x plus h minus e to the power of x divided by h in the limit where h approaches 0. Maybe I should have just reminded you, what is the derivative of any function? df to dx is fx plus h minus f over x divided h in the limit h approaches 0. So it's the difference between 2 points, 2 function values of f, and 1 point and 1 next to it, infinitesimally close, x plus h is very similar, close to 0, divided by that difference. Delta y over delta x, well, delta x is really close to 0. So in this case, I just put x plus h. That's the value of the function. Okay, what can we do? What can we do?
You take out an e to the power of x.
Correct. Factor e to the power of x. So I'm going to write it like this. I'll do a semi-step. E to the power x plus h is e to the power x times e to the power h minus e to the power of x divided by h. If you don't mind, I'm going to skip that lim. I should really write that limit. Now, as Jites said, I'm going to put e to the power x as the factor, and I'm going to have e to the power h minus 1 over h. And I will write down here limit h approaches 0. So what I want to do now is figure out what this thing is. Okay, the answer is going to be e to the power of x And what do I really want this number to be? Because remember, I'm trying to prove that the derivative of e to the power x is equal to the power of x. So what do I want this to be?
Equal h.
1. Well, yeah, you can say that. You want the top to be h. But I'm just going to calculate the whole thing. Obviously, if this is h, then h above h is 1. Okay? So I'm going to use this. Okay? So what I'm going to do now, I'm going to power both sides by h. So I'm going to have e to the power of h. What should I have on the other side? How do I do if I power that by h? I just have my grade 9 doing that. So 1 to the power 1 plus h to the power of what? I power this whole thing by h.
Which is be 1.
Yeah. Because if you power it by h, 1 over h times h is 1. Can you see that? And then, well, so I'm not going to even get rid of that 1, because obviously power 1 is power 1. Now, let's find out what is h equal, or e to the power of h minus 1 equal h. I'll just move the 1 to the other side, yeah? And that's what you want to show us. You know, you said e to the power of h is h. So this is really equal to limit h approaches 0, h over h. Now I can cancel. Forgot the e to the power of x. E to the power of x, h over h, which is equal to e to the power of x. There. Alright, so that's what I want to prove, yeah? Okay, cool. I'll pause here. Okay, so just before we start solving examples, let's just look again. What does that mean? It's actually, if I'm thinking about it, it's the only function that equal to its derivative, which is quite unique. So if I have x and y, and I want to plot e to the power of x, y equal e to the power of x, what would it look like? What kind of, what is the, it's exponential. Starting y-intercept will be? Yeah, e. Okay? Because when, no. What is the y-intercept when x is equal to? Naught. So what is e to the power of 0? 1. All the exponents, unless I have something in front, they always start at 1. If I have 2 e to the power of x, it obviously starts at 2. But if it's just something power x, it's going to start at 1. And then exponent, as you said, you guys know what exponent is. Okay? Now, what does that tell you? If you go to a certain point and you're trying to calculate the gradient, it can actually be equal to the y value. The derivative, the gradient here, is e to the power of x, which is the same as the value of the function. The value of the derivative is equal to the gradient. Just giving us an example. Let's say when x equals 2. What will be y of x equal 2? It's going to be e squared, right? The derivative, okay, at 2 is also going to be e squared. So the derivative and the value of y are going to be the same. That's unique as far as I can think of. Okay? There might be another one equation, y equals 0. If you think about y equals 0, what's the derivative of that function? Everywhere. 0, because it's a flat line. And the value is also 0 everywhere. So that obvious. Okay, let's do some questions and you know, Olivia asked what kind of example you can. Okay, so you obviously make things a bit more complicated, isn't it? So if I have, let's say, f of x equal 2e to the power of x plus e to the power minus 3x, and I want to find out the derivative. So my first rule is like, okay, I've got sum of two derivatives, two functions. Then I just need to find the derivative of each one of them and add them up, right? So I need to do 2e to the power of x, find the derivative of that, plus the derivative of e minus 3x, find the derivative of that, okay? All right, let's start with the first one. That's not too difficult. What do you reckon will be the derivative of that one? If the derivative of e power x is e to the power x, what will be the derivative of 2 times e to the power x. Okay? And why is that? Because we've got a rule that, okay, it's actually, you guys guessed, but I don't know if you really thought it through. The rule is if I have f times g, these two functions of x, and I want to find the derivative, yeah, then I must do the derivative of f times g plus f times the derivative of g. Okay? But now, why don't I have to do, well, I'm doing it. Okay, what is the derivative of, because I really should maybe be writing the derivative of 2 times e to the power x plus 2 the derivative of e of x. But what is the derivative of 2? What is, it's naught. Y equal 2, the derivative is naught. So that dies suddenly. Okay? So the answer is 2 to the power, 2 times e to the power x. It's kind of like, and we never really thought about it, but let's say we have 5x. What is the derivative of 5x? 5. Because the 5 remains. The x becomes 1, the 5 is still there, so it's 5. If I had 5x squared, what would be the derivative of that? 10x. The 2 jump multiplies the 5. So it comes from that. Okay, let's do the second one. This is a little bit more difficult. Now we have e to the power, not power x, but e to the power minus 3x. Let's hear some thought. I'm just going to pause here. Almost, Larissa. Okay, so the answer will be minus 3, so plus minus, okay, just minus 3, e to the power minus 3x. Now I'm going to try and explain why. What we're going to use here is the chain rule. Not the product rule, but the chain rule. And the chain rule works with the babushka, if you remember. F of g of x. If I want to find the derivative of f of g of x with respect to x, I got to do the derivative of f with respect to g and time it by the derivative of g with respect to x. Okay? So I'm just working on this one. Let's just write it down. So e minus 3x, d of that to d of x. Okay? So first of all, I've got a function. The function is e to the power of something. So the derivative of e to the power of something is simply going to be e to the power of the same thing. Remember that exponent e to the power of whatever, the derivative is initially the same. It's the same. Okay? But now I have to look at the derivative of the inner function of minus 3x. And what's the derivative of minus 3x? Minus 3. So I need to multiply it by minus 3. In other words, minus 3 times e to the power minus 3x. And we're going to do more of those. But let me just write it for you here. If you want to find out e to f of x, this is a really important one. You want to find out the derivative of e of f of x. So you have not e to the power x, but e to the power of some kind of function of x. The answer is going to be e to the power of f of x, just like we had e to the power minus 3x, but we need to multiply it by derivative of f of x. Okay? So that really is like the most general equation. Okay? That is actually inside here. Because if f of x is equal to, if f of x is equal x, if this is simply x like it is here, then the derivative of f of x is just 1. So this is inside that. Okay? More examples. So just a thought here, okay? Confusion, and I think it's really, really important that we explain that, okay? So you might want to say that e to the power of 3x, okay? And let's say, you got that minus 3 there, but you might want to say, oh, doesn't the minus 3x go down 1x, so shouldn't it be minus 4x? Okay? And the answer is no, it's not true. But I understand why you would think that, because you get confused with, let's say, this thing. If I have x to the power of minus 3, and you want to find the derivative, that is going to be minus 3 times x to the power of minus 4. Then it goes down. But you see, these things are very, very different. Here the x is at the bottom. We've been doing this a lot. Now for the first time we have the x as the exponent. And it's not true. This is not true. This is still going to stay minus 3x, just because, as I told you in the beginning, the derivative of e to the power of x is e to the power of x. It doesn't go down 1. Okay? It doesn't become e to the power of 1 or e to the power of 0. Okay? Right, I'll pause now. Okay, so what we're going to do now is just practice this and all the chain rule, the product rule with these functions. We're trying to find out the derivative of these functions. The first one, x squared e to the power of minus 6. Obviously, we've got the product rule here. So we're going to find the derivative of x squared. What is the derivative of x squared? 2x, timing it by the second function, and then x squared times the derivative of that. What will be the derivative of e minus x?
Well, that's also a chain rule.
That will be a chain rule.
Minus e minus.
Minus e minus x, correct. Okay, so the minus jumps out here, and you times by e minus x. We happy with that? Okay, so the answer is 2x e to the power minus x squared e minus x. You can factor it if you want, or just leave it like that, whatever they're asking. Okay, this is the quotient rule. Okay, we didn't write the quotient rule now. F over g derivative. Remember, what would that be? How would I do that? Derivative of f times g minus f derivative of g divided by good g squared. Okay, so the derivative of e to x. What is the derivative of e to the power 2x? That's it. E to the power 2x, and the 2 jumps up. And it stays 2x. It doesn't go down to x. Yeah? Time x minus e to the power 2x. What's the derivative of x? 1. So I leave it there. Divided by x. And I can just, divided by x squared into square denominator. Yeah? So it's going to be 2e to the power 2x divided by x minus e to the power 2x divided by x squared. You can maybe factorize it or whatever you want to do. Okay, a little bit more. Are you right so far? Pretty straightforward. Okay, that's a little bit more difficult. In these cases, I always recommend you to do what? How should I rewrite this? As a half. Okay, so almost a half is 2 times 2 to the power minus x plus 1 to the power of almost. Negative half because it's denominator. Yeah. Correct. Okay, so now I'm going to write the derivative of h here. Okay? Okay. What do we have? Which rule are we using here? What screams at you here? It's the chain rule. So I have a function, the inner function. At this point, I'm not even interested. Sometimes it might help you just cover it. I don't care what it is. I just know it's power minus half. So how should I write that? I'll copy what I've got here, e to the power minus x plus 1. What should I do with that? Power? What should I have right here? What's the fact? Minus half.
And then minus 1 half.
Minus 3 over 2. Correct? Now I need to time it by the inner function. What will be the inner function here? Negative 2. The minus jumps out there. Time?
E minus x.
E minus x. Alright, yeah. Okay? And look, you can write it in a, how would you write? I'll let you, it's fine. This is fine. You can make it a little bit prettier, but I think you guys figure out how to do it. Or should I show you how to write it maybe in a slightly different way? I'll show you. So I would say, okay, minus 2 times minus half, that's 1. That cancels out. So to be honest, it's fine. Just write it like that. 2e minus x plus 1 power minus 3 over 2 times e to the minus 6. There's nothing wrong with that, you know. In grade 9, maybe even grade 10, we asked to have positive exponents, but there's nothing wrong with negative exponents. Okay, I'll pause here. Okay, so just one more small example before we move to the more kind of long one. What about e to the power of x squared? E to the power of x squared. If I want to find the derivative. Okay? D to dx. Yeah, what do you reckon?
Do you find the derivative of x squared?
Yes. But so first of all, okay, this is my f. This is like my f of x. So first of all, I'm going to write, okay, e to the power of f of x. In other words, e to the power of x squared. Now I need to multiply it, like Lorenzo said, by the derivative of f. What's the derivative of f in this case?
2x.
2x. So the answer is 2x e to the power of x squared. Okay, and I didn't see that in the book, but there's no reason why you shouldn't be able to do it. Definitely should be able to.
Oh, so you just took the ex squared and you times it by
It's always that. You always, e to the power of whatever is going to be e to the power of the same whatever, but then you just multiply the derivative of that whatever.
Yeah.
That makes sense. Whatever. Okay? Right, so that's the basic stuff we need to know. Now we're applying it on things that, we're dressing it up again. The maths is the same maths. So we need to find the equation of the tangent to the curve e to the power of 2x minus 3x at the y-intercept. So we've got some kind of curve, e to the power of 2x minus 3x. It touches the y-intercept somewhere, and we want to find out the tangent to the curve. So the first step when we find any tangent to any curve, what do we need to do? Find the gradient for the curve. So in other words, we just need to find the derivative of f with respect to x. We need the derivative of that. What will be the derivative of e to the power of 2x? Correct. Minus 3. That is the derivative of that. Okay, so that's the derivative. Okay, now I actually need to find out the value in numbers. Right? I need to find the gradient because I know that my solution will be some kind of y equal mx plus c, where m is the value of the gradient, right? We've got some kind of curve. I don't know what it looks like. Probably looks like something like this. And I'm looking for that the equation of this graph. So I need to find out the m. The m is the gradient, right? So I need to substitute something. I need the number.
You need to work out the y-intercept.
Yes. Well, what is the y-intercept? I'm missing. What am I missing here? An x or an y? What am I looking for? X or y? Well, I don't have a y here. I need a number, right? This is a function. So I just need to know what the x is. But I know what the x is.
It's the same as your gradient.
It's simpler than that. They told me the equation at the y-intercept. What is x equal to? X must be 0, right? Because you said normally they will say find it at the point 2 or x equal 2 or x equal to 2.25, whatever. Here they told you in words it's at the y-intercept. The y-intercept meaning x is 0. Huh? Okay. I'm getting the function for the gradient. This is the function of the gradient. In different places, I'm going to have different gradients, right? So to get a number, because I need a number to put instead of m, I need a number, right? So I need to know what x am I working with. Is x equal 1, x equal minus 5, x equal, what is x equal to, Olivia? No, because it's in the y-intercept. Okay, so I'm going to put in x equals 0. What is that going to be equal? 2 to the power of 0 minus 3. Okay, 2, 0 is 0. What is that?
2 minus 3.
Minus 1. Okay? So m is equal minus 1. Minus 6. How do we find c? We sum. In other words, now we need to find the y-intercept. Okay? So the x, so I'm looking at this point. Okay? What is this curve? This is this curve. E to the power of 2x minus 3x. Okay? So I know when x is 0, if I put 0 here, okay, I need to figure out what is the y. How would I know what is the y? How would I find out y? I need to substitute 0 somewhere.
Yeah.
Where? The function.
Where the thing is.
Where the thing is. Okay? So I need to put 0 here to find what the y is. Okay? So I'm going to put f of 0. That's my y. That's this one. It's going to be e to the power of 0 minus 3 times 0. How much is that? 1. Because 3 times 0 is 0. E to the power, anything power 0 is 1. So it's 1. So this is the point 0, 1. So when x is 0, y will be 1. Okay? So I'm going to have 1 equal minus 0 plus c. In other words, c is equal 1. In other words, the answer really is, I'll write it down here, y equal minus x plus 1. That's my equation. Let me just going to see that I've got it right. Yes, we got it right. Okay, I'll just pause here. So our last question is to find stationary point for this function. Some kind of function x minus 2 times e to the power minus x. What is this? Where is the stationary point? It turns out I think there's only one. And what's the nature? In other words, is it a maximum? Is it a minimum? What was the other one that we called? I can't remember. I can't remember what even we called it.
Midpoint of
Say again?
inflection.
Inflection, point of inflection. Fantastic. Thank you very much. Okay?
The second derivative.
Yeah. So we will get to that. Yeah. We're actually not going to do the second derivative. We can, but at this point I'll do something a little bit different. Okay. So what's the first? Whenever they're asking about stationary point, something needs to come to mind. What do you do? What's the first thing?
Gradient.
Gradient. Okay. Well, we're in derivatives, so we're always going to find a derivative. So we're going to find dy to dx. So which rule are we going to? We're going to work with a couple rules, but the first one we have a product of two functions. So we're going to use the product rule. Okay, so we're going to find the derivative of x minus 2, which is 1. Time it by e to the power minus x plus x minus 2 times the derivative of e minus x, which is
A minus e minus.
good. So there's that minus jumps in there. I don't know where to write it. I'll write it down here straight away if you don't mind. So the minus will jump over there. Okay? Alright, let's write it a little bit prettier. So it's going to be e to the power minus x e to the power minus x plus 2 e to the power minus x. I just open this brackets. Okay? So, and then there's one last thing I can do. I can put these guys together. So it's 3 e to the power minus x e to the minus x. In fact, in this case, what do you want to do? And it will help us. So let's do it. Group it. Factorize it. Okay? So we'll get e to the power minus x, 3 minus x. That will be bigger. Okay? Because, why is that better? What's the next step we got to do to find a stationary point? Do you start at calculus?
Like today.
That's it. So this is really helpful. Okay? So to find a stationary point, what does the gradient, the derivative, have to be equal to? Naught. Okay? For stationary point,
Basically just solve the equation.
yes, the derivative has to be equal to 0. So I'm going to write e minus x, 3 minus x equals 0. Okay? Now, if you look at it, you would think maybe there's two solutions. Let's start with the obvious one. For which x this whole thing is going to be 0? What's the most obvious if you have to guess?
Minus 1.
One.
I mean, no, but the x on top of the e has to be 0. Do you know what do you see what?
Let's leave him for a second. Let's come back to him for a second. How is this going to be 0? That's more obvious, isn't it?
Yeah.
3. Okay? So 3 is definitely a solution. Definitely a solution. Let's, from that point, also find the y. Why do I want I? I want to know what the y, because I want to find the coordinate. So what will y be equal? I'm just going to put x equal 3. Okay? So 3 minus 2 times e minus 3. What would that be equal to? And I'm not looking for a decimal place. But what is 3 minus 2? 1. So e minus 3. Huh? Or if you want to write 1 over e cubed, if you want to write like that. Okay, now Olivia actually started with this term, and Olivia said, okay, but sir, am I recording? Yeah. Olivia's tried to actually start with this one. He said, when is that going to be 0? For which, or let's say, when is this 0? Okay, I'll put question mark. You'll see in a minute why. What must x be equal to? You were thinking maybe 0 or 1 or 1. Well, if x is 0, e minus 0, what is e minus 0? Is e power 0. What is any power 0? 1. So it's not that. It's not going to be 1 as well, because e power minus 1 is 1 over e. It's not. What does x actually have to be 0? What does x have to be for this whole thing to be 0? Infinity, right. If x is infinity, e minus infinity is 0. Okay? So, look, they didn't ask us to draw this curve, so I'm not going to draw it, but I'm going to sketch maybe a couple of points. There is some kind of stationary point. What is stationary point? You know what it is. The gradient is 0 at x equals 3. So there's going to be some kind of, I don't know, I'll just draw one option, maybe like this. So there's some kind of stationary point. Then this one, it will go down. It is not going to be 0. I don't know what's going to happen here. The next time the 0 is infinity. So maybe it goes down like to here. Maybe there's some kind of asymptote. But that's an infinity. Infinity is not an answer. I can't give you. So there's only one. Is what I'm trying to say. There's only one coordinate. 3 and e to the power minus 3. That's the only answer. Okay? E to the power minus x is never 0 for any real number, which is not infinity. Okay? I'll just pause here. So now, to finish this question, we found the stationary point. Stand here, but they're asking us also to find the nature of that point. What does it mean, nature? We said maximum, minimum, one point of inflection. Normally, Olivia already mentioned we should be going through to the second derivative. And if the second derivative is positive, then it's a minimum. I won't ask you. Is that right? Yes. So smiley face. The second derivative is positive. Okay, that means it's a minimum. If the second derivative is negative, it's a maximum. If the second derivative is 0, yes, but I think we need to figure out, we need to figure out for sure. Oh wait, I'm not going to think about it now, because it's not going to be inflection, so let's leave it. Now, to find the second derivative, we need to do the derivative, which is fine, but actually, what they did in the book, and I'll follow them, is to do something else. And I think it's just something that I often don't do, so it's probably a good thing I'll do it now. Okay? I'm looking for the second derivative, for the first derivative. Now, when x is 3, the first derivative is 0. What I'm going to try and do is find what happens to the first derivative. Okay, so this is the first derivative. What happens a little bit before and a little bit after 3. Okay, remember I did it once. I didn't do it enough, so I think let's do it again. So what we can do is write, we can look at what's the first derivative. I mean, what's the first derivative? Okay, the f prime is simply that. E minus x, 3 minus x. Now, you might think, oh, this is actually difficult. Actually, it's really easy. Because whatever x is here, what is this going to be? This is going to, I'm not looking for numbers, I'm just looking for positive or negative, remember? Okay. This is always going to be positive. What is e to the power minus x? Is 1 over e to the power of x. Doesn't matter what x is, this thing is always positive, right?
Okay.
Yeah, e to the power of 1, e to the power of minus 5, it's all positive numbers. Yeah? E to the power of minus 5 is 1 over e to the power of 5. What is e to the power of 5? Yeah. Okay, it's a positive number. I don't know what it is, but it's a positive number. E times e times e times e. I'm just going to pause. They're not going to hear me. Okay, so maybe I should have explained in the beginning. What am I trying to do here? I know the derivative here is 0 at 3. I'm looking to find out what's the derivative on either side. If the derivative here was positive and here was negative, that means the graph was going up, then it was stationary, then it was going down, meaning it's a maximum. If it was the other way, if this is minus and this is plus, then it was going down first, then it was stationary, it was positive, that means it's minimum. If it was positive here, 0 and then positive, that means it went up, stationed, flattened a little bit, and then went up again. What do we call that? You guys reminded me today. Inflection. And the same thing if it was minus and minus. So that's what I'm trying to find out. Now I can see that the derivative is made of 2 parts. This and that. And this I was trying to convince you, whatever x you put here, it's always going to be positive. That can never be negative. Because it's e to the power time, e time, whatever time, any times, or 1 divided by e time. This is always going to be negative, positive. So whether this is positive or negative on either side depends on 3 minus x. And 3 minus x is so easy to find out, right? What is 3 minus x when x is smaller than 3? Okay, when x like 2.9 or 2.2, it's positive. And when x is larger than 3, negative. Okay? So it is going up, 0 and then down, it's a maximum. You're right, so I'm going to write it down here, it's a maximum. Okay, I'm just going to check that we got it right. Maximum turning point. Okay, so I don't know what, maybe just calculating the second derivative would have been easier, but it's also good to understand this kind of reason. Okay, that's it for today.